The multiple launch rocket system is the most powerful artillery system in the world. Currently fielded by the U.S. Army, it will soon be in the armies of the Federal Republic of Germany, Great Britain, France, and Italy. Product of the LTV Aerospace and Defense Company's Vought Missiles and Advanced Programs Division, the Multiple Launch Rocket System, called MLRS, is assembled in Camden, Arkansas, using systems and components produced not only by LTV, but also by more than 15 major subcontractors and several hundred other subcontractors from across the entire United States. The town of Camden is nestled in the flat, densely forested plains of south-central Arkansas. It is, in many ways, a typical small Arkansas community, with a bustling business district surrounded by well-kept older homes. What makes Camden unique was Shumaker Arsenal, a major producer of naval ordnance built during World War II. Production continued at the arsenal for a number of years after the war, long enough for the people of Camden to become thoroughly munitions-oriented. When LTV won the MLRS contract in 1980, a dedicated ordnance facility was required. But Camden's arsenal had been shut down for several years, and its experienced workers were idle. It was a perfect situation for LTV, the people of Camden, and the MLRS program. To shorten a long story, LTV, the Brunswick Corporation, and the Atlantic Research Corporation, using Camden's willing and experienced labor force, built a new facility, installed modern computer-controlled equipment throughout, and created the most advanced automated ordnance production complex in the world. This complex, which contains more than 500,000 square feet of floor space, is situated within 1,500 acres of secured property. Now, let's take a look at the major parts of the MLRS weapons system. The basic carrier vehicle is received as government-furnished property direct from the FMC Corporation in San Jose, California. The Launcher Loader Module, or LLM, mounts on the rear of the carrier vehicle. It contains all of the mechanical, electrical, and hydraulic systems to accurately aim and launch the rockets. 2 rocket pods fit inside the LLM. These are self-loaded by the integral LLM boom actuator and hoisting systems supplied by Plessy Dynamics Corporation and the Breeze Eastern Corporation, respectively. Each pod contains 6 rockets, for a total of 12 for each LLM load. Most non-pyrotechnic components and non-vendor items are fabricated and assembled in LTV's modern metal parts building. Here, 4 basic production lines are under one roof. These comprise the launch vehicle assembly line, the rocket motor case manufacturing line, the rocket pod fabrication line, and the warhead skin and detail fabrication lines. Now let's take a tour of the 217,000 square foot metal parts building. Our first stop is the launch vehicle assembly line. The LLM attaches to the bed of the FMC-supplied carrier vehicle. The 3 major components of the LLM are the base assembly, the turret assembly, and the cage assembly. The basic structure of all 3 assemblies are fabricated by LTV in the huge Jefferson Boulevard facility in Dallas, Texas, where all MLRS weldments are produced. Here, a total of 75 detail parts are precision machined, aligned in special fixtures, and welded to form the base assembly structure. There are approximately 5,000 linear inches of weld bead in the base structure alone. The turret assembly is made of 150 detail parts that are machined in-house, critically aligned, and then welded together. This structure requires more than 17,000 linear inches of weld bead to complete. The massive cage structure, like the base and turret assemblies, is welded together with aerospace precision. Comprising 217 detail parts and requiring 19,600 inches of weld beads to complete, the cage assembly is fitted with armor plates of Alcoa aluminum on each side to protect the loaded rocket pods. After processing, inspection, and painting, all 3 basic LLM structural assemblies are transported to Camden by LTV trucks. In Camden, workers install the launcher drive system manufactured by Vickers Incorporated, the azimuth drive system from the Western Gear Corporation, the huge azimuth bearing from Rotec Incorporated, and associated equipment to complete the base assembly. The complete base assembly is then installed to the mounting frame on the vehicle bed. The elevation actuators, manufactured by Beaver Precision Products, are installed on the turret assembly, along with the elevation transmission from Plessy Dynamics Corporation and the servo motor from Allied Bendix Aerospace. The angle drive unit is made by the Hub City Company. The completed turret assembly is installed on top of the base assembly. At Camden, the top armor plate of Alcoa aluminum is added, along with the boom assembly and actuators from the Plessy Dynamics Corporation. The hoist and control box are supplied by the Breeze Eastern Corporation. When the completed cage assembly is installed on the turret and base assemblies, the launcher vehicle has its final shape. However, there's still a lot more work to be done. Completing the launch vehicle are the fire control system and communications processor from Norden Systems Incorporated, the stabilization reference package and position determining system from the Guidance Systems Division of Allied Bendix Aerospace, the short no-voltage tester from Cherokee Nation Industries Incorporated, the power distribution and battery box installations from Red Wing Products, and many other cables, switching devices, radios, and related equipment from dozens of suppliers across the United States. These are the components and systems that make MLRS the most accurate rocket launcher in the world. But there's still another important step: final checkout and inspection. For example, the 6 alignment pads in each rocket pod bay are optically checked for critical alignment with the stabilization reference package. This bore sighting operation assures precision aiming accuracy. The mechanical systems, such as the built-in hoist mechanism, are thoroughly tested to ensure that they function properly in loading and unloading the rocket pods. A complete simulated firing sequence is input to the fire control computer to verify that the entire system is operating correctly and effectively. During this simulated fire sequence, the launcher loader module gets a thorough workout. As a final test, the launch vehicle is driven over a special test track designed to simulate actual operations in the field. The test covers 50 kilometers. The launcher loader undergoes 8 separate cycles of loading and unloading the rocket pods. "40 simulated fire missions are performed to prove system operation and accuracy. These practice firing missions are directed by the platoon leader's digital message device, manufactured by the Magnavox Electronic Systems Company. Only after all tests and checks are completed is the vehicle cleaned, painted, and prepared for delivery. LTV's rocket pod line actually starts about a mile down the road here at the Brunswick Corporation, where the rocket launch tubes are fabricated. Brunswick's unique filament winding technology allows the integral forming of the internal spin rails and the launch tube body as a single unit. The spin rails act as rifling to spin the rocket and help give it stability in flight. When rail winding is completed, the tube body is formed by wrapping helical and circumferential layers of fiberglass roving over the forming mandrel. This microprocessor-controlled operation automatically lays a band of fiberglass in a precise pattern to ensure launch tube precision. The launch tubes are then heat-cured, cooled, and the forming mandrel extracted. After 4 hours in a post-curing oven at 225 degrees, the tubes are automatically cut to length, drilled, slotted, and trimmed to the precise exterior dimensions for rocket pod assembly. After cleaning and final inspection, the launch tubes are trucked to the LTV assembly line for incorporation into the rocket pods. Back at LTV's metal parts building, the rocket pod line comprises both fabrication and final assembly areas. Here, aluminum bulkhead castings from the Permanent Mold Castings Division of Alcoa are being processed in a numerically controlled machining center. The aluminum hoist beam castings are processed by a machine that handles the milling and drilling operations on both the left and right side parts in one setup. These will be joined with the shear webs from the Tri-Cities Tool and Die Company and the main bulkheads to form the center torque box structure. After inspection, detail parts are placed on the overhead conveyor system, chemically processed, painted, and returned to the appropriate assembly staging area. During rocket pod buildup, detail parts are positioned in special assembly fixtures where they are riveted together with computer-controlled automatic riveting machines. The electronic cable harness from Cherokee Nation Industries, which includes the gold dot umbilical from Hughes Aircraft Company, is then installed. The launch tubes from Brunswick are inserted into the assembled rocket pod structure. The tubes are drilled by automatic equipment for installation of the holding and alignment pins. Stencils are then applied, and shock absorber skids from Barry Controls Company are installed. After both electrical and structural inspections, the rocket pod is moved to the rocket loading area in the ammunition handling building. The rocket motor assembly process starts in the metal parts building. The deep-drawn motor case blanks are received from NI Industries. At the microprocessor-controlled machining center, each case is machined and inspected. Each case is thoroughly washed and degreased. A shot blast process removes all residual scale. Cases move down the conveyor line where the fin lug, spin lug, and rider lug castings from Hitchner Manufacturing Company are precision spot welded using one of 6 computer-controlled welding machines. The lugs are machined to precise tolerances, since they help stabilize and guide the rocket as it moves down the launch tube during firing. Finally, each case is pressure tested to ensure that it will stand up to the high pressures of burning solid propellant. After testing, cases go by automated conveyor to the paint shop. The motor cases are then trucked less than half a mile to the Atlantic Research Corporation's plant for loading with solid propellant. Here, each case is placed in a holding fixture, and a mandrel is inserted to form the propellant configuration. The solid propellant is poured into the motor case in a semi-solid state. The pouring operation is performed in a vacuum. This ensures that the propellant conforms precisely to the interior of the case and is free of voids and bubbles. The volume and weight of propellant in each rocket are precisely measured, since the propellant significantly affects the range and accuracy of the MLRS rocket. After the mandrel is removed, the rocket nozzle is installed. Then the completed motor is leak checked and inspected. Each rocket motor is 100% X-ray inspected to ensure that the propellant is properly loaded. The completed rocket motors are trucked back to LTV for joining with the warhead. Warhead buildup also starts in the metal parts building, where the deep-drawn aluminum skins are received from NI Industries. After inspection, the skins are moved to a special machine where 4 grooves are cut longitudinally to aid skin separation when the warhead is activated over a target. The nose body castings from J&E Die Casting Division are machined and then installed on the warhead skin. The skin assembly is then moved to the rocket assembly line in LTV's warhead assembly building. Handling the pyrotechnic components of the MLRS rocket motors and warheads requires heavy emphasis on precision and safety. Even the layout and construction of this renovated ordnance facility are designed to reduce the chance of an accident and to isolate it should one occur. Notice that almost every step in the ammunition handling process is isolated in a small cell, separated from adjoining cells by thick steel-reinforced concrete walls. The basic MLRS rocket assembly is about 13 feet long, 9 inches in diameter, and weighs about 675 pounds. Keep in mind as we tour the plant that one of these rockets is produced every 3 minutes. In this cutaway drawing, you can see how the 644 grenades are positioned and insulated by the polyurethane foam supports. When the grenades are dispensed from the warhead, this foam will be fragmented by the dispensing force. The M77 grenades, manufactured by Day and Zimmerman Incorporated, are shipped to Camden from both the Lone Star Army Ammunition Plant in Texarkana, Texas, and the Kansas Army Ammunition Plant in Parsons, Kansas. The safety pins and clips are removed by automated machines that are faster, more accurate, and far safer than even the most highly trained worker. The warhead foam packs are molded in the metal parts building and transported to the warhead assembly building. Although they may appear identical, these packs vary in size and shape depending on their intended location within the warhead envelope. The foam packs are placed in temporary clamping devices for proper alignment during grenade loading. The M77 grenades are automatically inserted into the foam packs in this cell. The loaded packs are segregated in a staging area in the correct order for warhead assembly. The foam pack sections are then transferred for warhead buildup. The metal clamping devices are temporarily joined to align the foam packs to the inside contour of the warhead skin. After the foam pack stacks are positioned upright, the metal forms are removed and the packs are moved to the next cell by conveyor. At the same time, the warhead skin assemblies are also moving by conveyor to the same cell. Here, the skin assembly is installed over the stacked foam packs. The center core burster charge, an explosive component from the Ensign Bickford Company, is inserted down the center of the foam packs and secured. The aft bulkhead from J&E Die Casting Division is then installed, securing the loaded foam packs in place. At this time, the completed rocket motor assemblies received from Atlantic Research Corporation are transferred to the rocket assembly conveyor. The 4 stabilizing fins are installed on each motor assembly. The warhead and solid propellant rocket motor assemblies are joined to form the MLRS rocket assembly. The complete rocket assembly is then dynamically balanced to assure precise aerodynamic alignment for stability in flight. The pyrotechnically actuated fin restraints, another Ensign Bickford Company contribution, are installed. The rocket is moved to the paint booths for final touch-up. The rockets are then moved by conveyor to the rocket pod loading area. Here, as in almost every step of fabrication and assembly, the precision of the task dictates the use of automated equipment. After the rockets are secured in the launch tubes, the warhead activation fuses from KDI Precision Products Incorporated are installed. The rocket motor igniter is connected to the electrical harness to complete the firing circuit. A remote electrical continuity check verifies that the rocket will fire properly. Then the rocket motor igniters are installed in the nozzle. Each launch tube is then protectively sealed by 2 tube covers with fast cure adhesive. The plastic forward tube cover is made by the Techstar Plastics Company, and the steel rear cover is made by the Tri-Cities Tool and Die Company. A pressure leakage test determines that the now complete rocket pod is properly sealed and will protect the enclosed rockets for the minimum 10-year storage life of the ammunition. These rockets will need no maintenance or servicing from this point up to and including their launch during a fire mission. This brief tour of the MLRS production complex in Camden and the LLM fabrication facilities in Dallas was not designed to include every detail of the manufacturing and assembly process. Rather, it was more of an overview of the world's most modern weapons system operations, dedicated to the production of the world's most effective rocket artillery system. The people of Camden who build MLRS, as well as the many contributors across the United States who supply various systems and components, are very much aware of their responsibility to make MLRS a reliable, high-quality weapons system. If MLRS is ever called to defend freedom anywhere in the world, its contributions could be the key to ultimate victory.